In the boundless expanse of space, a presence of profound mystery and wonder emerged, captivating our collective imagination and perplexing scientists scattered across the globe. This cosmic enigma, an interstellar object unlike any seen before, seemed to defy every known law of astrophysics. It moved with a velocity unbound by our solar system's gravitational leash, and bore characteristics that puzzled even the most seasoned astronomers. From the moment it entered our view, this celestial wanderer, later named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first, became the center of scientific fascination and debate. Its trajectory indicated an origin beyond our solar system, marking the first known interstellar object to pass through. But it wasn't just its origin that intrigued experts. It was everything about it. It was long and narrow, unlike any comet or asteroid previously documented. It lacked a visible tail of gas or dust, traits expected from a comet. Yet it accelerated in ways that suggested forces beyond gravity were acting upon it. Was it a rogue asteroid? A comet without a tail? Or something far more extraordinary? As telescopes across Earth turned to the skies, capturing fleeting glimpses before it vanished into the darkness, the mystery deepened. The scientific community raced to explain its erratic movement and strange shape. Theories ranged from exotic natural formations to more provocative possibilities like alien technology, a light sail or probe from another civilization. Yet while the brightest minds of the scientific community struggled to fathom the nature of this interstellar anomaly, something even more profound was on the horizon. A pivotal shift in how we view the universe. Oumuamua was not merely a space rock, it was a cosmic message, a wake-up call, that our place in the universe is not as isolated as we once believed. Its arrival reminded us that space is not static, it is dynamic, full of surprises, and teeming with phenomena that challenge our understanding of reality. As we continue to search the skies for signs of similar visitors, the legacy of Oumuamua endures, as a harbinger of the unknown and a testament to the enduring quest to answer one of humanity's greatest questions: are we truly alone in the universe? The momentous advent of NASA's James Webb Space Telescope, JWST, marked a turning point in our quest to understand one of the most compelling cosmic mysteries of our time. Heralded as the most powerful space observatory ever constructed, the JWST was designed to peer deeper into the universe than any telescope before it, capable of detecting the faintest whispers of light from galaxies billions of years old. But alongside its grand mission of unlocking the secrets of the early universe, it also offered humanity a unique opportunity to revisit the enigmatic visitor that had slipped through our solar system. Oumuamua, with its cutting-edge technology featuring a 6.5-meter gold-coated mirror and highly sensitive infrared instruments, the JWST represented the pinnacle of human ingenuity. Its deployment into space was a feat of precision and patience, unfolding over weeks like a cosmic origami in zero gravity. Once fully operational, its gaze turned not only to the distant past of the universe, but also to the mysteries that had recently crossed our own galactic doorstep. Oumuamua had left behind more questions than answers. It had long vanished into the dark beyond the reach of Hubble or any ground-based telescope. But JWST's instruments were more than just eyes. They were archaeological tools for cosmic history. Through a combination of advanced tracking data, simulation models, and deep sky observations, scientists used JWST to extrapolate details that had previously evaded every other telescope. Then came the moment. From the intricate web of data and imagery, a revelation emerged. A reconstructed view of Oumuamua, one grounded not in speculation, but in cutting-edge observation. For the first time, humanity glimpsed a true depiction of the interstellar traveller, not as a vague blur, but as a detailed celestial object. Its elongated shape was confirmed, its composition better understood, and its behaviour now more clearly modelled. This new image, and the science behind it, did not just illuminate the story of a single interstellar object, it expanded the narrative of our universe. The JWST had provided proof that such visitors were real, tangible, and perhaps not as rare as once believed. For Oumuamua was no longer a ghostly blur from a distant star system. It was now a defined character in the unfolding story of cosmic exploration. And yet, the mystery was not entirely solved. Even with JWST's incredible clarity, questions still lingered. Why did it accelerate the way it did? What was its exact composition? Was it a natural fragment of an alien world, or something far stranger? As JWST continues to survey the cosmos, its revelations remind us that the universe is not just a silent expanse, it is a storyteller. Each star, each galaxy, and each interstellar visitor carries a message, waiting to be heard by those willing to listen. The story of Oumuamua, illuminated by the brilliance of JWST, is a profound reminder that we are at the very beginning of understanding what lies beyond. But what was it truly? Could it be that this enigmatic visitor from the distant reaches of the cosmos was not merely a chunk of rock or ice, but something more? A harbinger of an otherworldly origin, as a bold few in the scientific community dared to propose? This question, teetering between the boundaries of science and speculation, invites us on a journey unlike any other, a journey that doesn't just study the stars. It challenges the very foundation of how we define the universe and our place within it. To gaze upon Oumuamua is to peer into a cosmic riddle wrapped in starlight. It arrived silently, without warning, hurtling through our solar system at a speed and trajectory that defied conventional celestial mechanics. Its shape, long, narrow, and eerily cigar-like, was unlike anything we've ever observed. Its motion, too, baffled experts. It accelerated away from the sun without any visible outgassing or tail, a behavior inconsistent with comets, asteroids, or any known natural body. This anomaly sparked whispers. Could it be artificial? Among those captivated by this mystery was Harvard astrophysicist Avi Loeb, who famously posited that Oumuamua might be a piece of alien technology, a light sail perhaps designed by an intelligent civilization to traverse interstellar distances. To many, this theory was outrageous. To others, it was exhilarating. After all, should we not remain open to the extraordinary when faced with the unexplained? This line of inquiry propels us deeper into the voyage of cosmic discovery. Not only do we examine the object itself, but we are also compelled to examine our assumptions. What if our definitions are too narrow, our expectations too limited? What if the universe is not only more vast and more ancient than we imagined, but more populated? As we traverse this intellectual and scientific frontier, we find our perceptions bending under the weight of possibility. Oumuamua becomes more than a visitor. It becomes a mirror, reflecting our hopes, fears, and deepest curiosities about what or who might be out there. Perhaps it was merely a natural interstellar shard shaped by forces unknown to us. Or perhaps it was a relic, a derelict probe from a civilization so far advanced that we cannot yet comprehend its purpose or origin. The truth remains elusive, dancing just beyond the reach of our instruments and our current understanding. Yet in its wake, Oumuamua left something powerful, a question. And it is in asking this question, without fear, without cynicism, that we affirm one of humanity's most beautiful traits, our boundless curiosity. We are not merely content to observe the universe, we seek to understand it, even when that understanding requires us to step into realms of wonder that border on the mythic. In the silence of space, Oumuamua whispered a message to us, a message not written in language, but in motion, form, and mystery. And as we unravel its intergalactic puzzle, we find ourselves not just looking outward, but inward, rethinking who we are, what we believe, and how far we're willing to go in pursuit of the unknown. This is not just a story about an object that passed through our sky. It is a story about us and the infinite universe that beckons us forward. Dimension of cosmic understanding creaked open. Oumuamua, named after the Hawaiian term meaning a messenger from afar arriving first, was no ordinary object. It raced through our solar system at a velocity that defied conventional classification, a silent harbinger of secrets written in the language of stars and time. Scientists scrambled to decipher its origin, composition, and trajectory, piecing together data with urgency and awe. This was not merely a flyby. It was an encounter, a fleeting brush with something ancient and untamed, forged in the dark interstellar abyss. Unlike any asteroid or comet ever recorded, Oumuamua exhibited no coma, no tail, no typical signs of outgassing. Yet it accelerated as if nudged by an invisible hand. The implications were staggering. Either our models of celestial dynamics were incomplete, or this object was propelled by mechanisms previously unknown, or perhaps unnaturally designed. And so began one of the greatest scientific puzzles of the 21st century. What was this elongated wanderer glinting as it spun through space, reflecting sunlight in strange and variable ways? Its brightness fluctuated dramatically, suggesting an object tumbling through space in an uncontrolled rotation. Yet, unlike any rock from our solar system, its shape and motion hinted at an origin utterly foreign. As telescopes across the globe turned toward this mysterious interloper, it became clear that time was against us. Oumuamua was already racing away from the inner solar system, its moment of closest approach already past. The window to observe and understand it was closing fast. Still, in those precious weeks, astronomers gathered what data they could, chasing an enigma that had travelled for millions, perhaps billions of years, only to spend a fleeting few weeks under human scrutiny. What made it even more profound was this. Oumuamua was the first of its kind ever detected. Never before had we directly observed an object from another star system entering our own. The universe had spoken, and we had just begun to listen. Speculations abounded. Was it a fragment of a shattered exoplanet, flung into the void by a celestial cataclysm? A cosmic iceberg of exotic ices, shedding invisible hydrogen as it neared our sun? Or could it be something else? A remnant of an ancient civilization, a probe designed not to communicate but to observe, silently, efficiently, then move on? While the scientific community leaned toward natural explanations, even the most conservative models struggled to account for all of Oumuamua's oddities. The debate raged on, papers were published, conferences convened, and always the object itself drifted farther and farther away, shrinking into a pinpoint of light, then fading beyond the reach of our most powerful instruments. But its legacy endures. Oumuamua awakens something profound, a realization that our solar system is not isolated, that the void between stars is not empty, and that we are part of a far greater cosmic story than we had ever imagined. In its wake, humanity found renewed purpose. Plans were drafted to launch intercept missions for future interstellar objects. Instruments were refined, strategies reshaped, and minds inspired. If another messenger comes, we'll be ready, not just to observe but to follow, to reach, perhaps even to touch. And so the celestial saga of Oumuamua marks not an end, but a beginning, a call to lift our eyes skyward with fresh wonder, a whisper from the stars that says, "We are not alone in this cosmic ocean, and the journey has only just begun." And with it, hope surged anew. Though Oumuamua was fast receding into the void, the James Webb Space Telescope, JWST, brought with it capabilities unlike any observational instrument before it. Designed to peer deeper into the universe than ever before, JWST was not merely a telescope, it was humanity's eye into the ancient past and the distant and now the eye turned toward a singular, vanishing point in our cosmic periphery. With each second that passed, Oumuamua moved further away, fainter, more elusive, and shrouded in mystery. Yet the infrared capabilities of JWST allowed scientists to probe for subtle thermal signatures, offering clues that visible light could never reveal. Data streamed back, complex, rich, mysterious. Every spectrographic line, every pixel captured by JWST's detectors held the potential to rewrite what we knew, or thought we knew. About. What was it made of? Was there outgassing? Did it behave like a comet cloaked in unfamiliar ices, or was its propulsion due to something more exotic? Perhaps a structure so thin and light it rode on solar radiation like a cosmic sail. Theories blossomed as the data trickled in, ranging from the conservative to the spectacular. Some suggested it was a fragment of a Pluto-like exoplanet, with an icy composition of hydrogen that evaporated invisibly in sunlight, giving it the strange acceleration observed. Others posited more radical ideas. A light sail of artificial design, crafted by an alien intelligence and sent across the stars on a silent reconnaissance. Whatever its nature, Oumuamua had become a celestial catalyst, igniting a renaissance in interstellar science. NASA and space agencies across the world began envisioning missions specifically designed to intercept future interstellar visitors. Missions that could launch on a moment's notice, outfitted with the tools to analyze, capture, or even return samples. The shockwaves that Oumuamua sent rippling through the scientific community continued to resonate. It shattered assumptions about the frequency of interstellar visitors, once considered nearly impossible to detect, now seen as inevitable. And with new surveys like the Vera C. Rubin Observatory and missions such as ESA's Comet Interceptor on the horizon, we stand ready to meet the next cosmic nomad. But Oumuamua's greatest legacy may not lie in its composition or trajectory, but in the questions it forced us to ask. How many other interstellar travelers pass through our solar system unnoticed? What secrets do they carry? Ancient histories of alien worlds, or the whisper of civilizations unknown? And perhaps most poignantly, what else is out there, waiting to be discovered. In the quiet that followed Oumuamura's departure, humanity was left with more than just mystery. We were left with purpose, a renewed sense of exploration, a deepened thirst for knowledge, and a profound understanding that we are not isolated specks in a cold void, but participants in a vast and dynamic universe, where messages may arrive on trajectories not written by human hands. And next time, we will be ready. With its state-of-the-art instruments, the James Webb Space Telescope, JWST, emerged not just as an observational tool, but as a technological sentinel tirelessly watching the celestial horizon. This marvel of engineering granted humanity unprecedented access to the hidden secrets concealed within the universe's most enigmatic wanderers. For the first time in history, we had a window not merely to observe, but to truly understand. More than a telescope, JWST became a bridge between worlds, a cosmic conduit linking Earth's curious minds to the vast and ancient corners of the cosmos. With its unmatched sensitivity to infrared light, it pierced through veils of cosmic dust, unveiling stars in their infancy, galaxies at the edge of time, and interstellar visitors like Oumuamua, whose mystery had long evaded clarity. Every photon it captured carried a message from across time, some billions of years old, now decoded by JWST's precision instruments. It transformed faint flickers of distant objects into vivid portraits, each pixel enriched with the story of a star's birth, a planet's atmosphere, or a foreign object passing silently through our solar system. As the telescope's golden mirrors aligned and its cryogenic instruments hummed in harmony, JWST did more than observe. It wove together a living tapestry of the cosmos. These weren't just images, they were histories, futures, possibilities, an atlas of the unseen, stitched together in infrared brilliance. And as its lenses focused, and its detectors recorded the light of ancient and alien realms, it felt as though the telescope itself were a cosmic traveller, embarking on an odyssey not through space but through knowledge. Each revelation brought us closer to understanding the grand design of the universe, revealing that behind every shadow lies a story waiting to be told. In the silent vacuum of space, JWST speaks for us, asks for us, seeking answers to the greatest questions ever posed. Thus, the James Webb Space Telescope is not just a machine, it is our ambassador to the infinite, a shining testament to human curiosity, collaboration, and our unyielding desire to explore the unknown. As interstellar objects danced within the focused gaze of the James Webb Space Telescope, JWST, their faintest whispers of light, once elusive and invisible to the naked eye, were brought to life with breathtaking clarity. Structures that were once shrouded in cosmic obscurity now emerged like brushstrokes on a galactic canvas, revealing intricate details and previously undetectable features. What was once the stuff of speculation became visible reality. The JWST's advanced infrared sensors transcended the limits of earthbound observation. Free from atmospheric distortion, it observed the cosmos from the cold stillness of space, offering humanity an unfiltered lens into the secrets of the universe. With each carefully calibrated movement, the telescope captured gigantic mosaics, stitched from thousands of smaller images, creating mega-images that encapsulated the full essence of celestial wanderers like Oumuamua and other deep space anomalies. This was more than mere observation. It was a symphony of technology, a harmonious blend of cutting-edge engineering and the natural splendor of the universe itself. Every data packet sent back to Earth echoed with the brilliance of human ingenuity, whispering stories of stars, comets, and interstellar visitors written in photons across time. Yet, while the James Webb Space Telescope basks in the glow of its revolutionary achievements, it is crucial to recognize the remarkable contributions of its terrestrial predecessor, the Pan-STARRS-1 telescope. Perched atop Haleakala volcano in Hawaii, the Panoramic Survey Telescope and Rapid Response System, Pan-STARRS-1, was the first to lay eyes upon the mysterious visitor Oumuamua on October 19, 2017. It was this ground-based marvel, designed for wide-field imaging of the night sky, that first detected the anomaly travelling at an extraordinary speed from beyond our solar system. In doing so, Pan-STARRS-1 etched its name into scientific history as the instrument that opened humanity's eyes to the existence of interstellar objects passing through our cosmic backyard. Without Pan-STARRS-1, there would have been no discovery, no intrigue, no international rush to understand the nature of this silent voyager. The telescope's constant vigilance and high-resolution surveys of the heavens made it the unsung hero of one of the most important astronomical discoveries of the century. Together, JWST and Pan-STARRS-1 represent two ends of a grand continuum, one scouting the skies, the other peering deep into the soul of the universe. Their combined legacy is a testament to global scientific collaboration, where earthbound observers and spacefaring instruments work in unison to decode the language of the cosmos. As more celestial messengers like Oumuamua arrive, carried by the tide of interstellar space, these remarkable instruments ensure that we are watching, waiting, and ready to understand. Perched atop the majestic summit of Haleakala in Maui, Hawaii, the Pan-STARRS-1 telescope rose not just as an instrument of science, but as a beacon of human brilliance, perseverance, and global collaboration. Its silhouette against the starlit sky is more than picturesque. It represents the collective ambition of humankind to understand the universe and protect our home within it. This visionary endeavour was the result of a unified effort among prestigious institutions. The University of Hawaii's Institute for Astronomy, the MIT Lincoln Laboratory, the Maui High Performance Computing Center, and Science Applications International Corporation, SAIC. Together, they gave life to the Pan-STARRS project, a mission conceived not just to observe, but to actively monitor and decode the ever-shifting tapestry of the night sky. With its 1.8-meter diameter mirror, Pan-STARRS-1, short for Panoramic Survey Telescope and Rapid Response System, was designed for wide-field imaging, capturing vast sections of the night sky in a single frame. It became a celestial sentinel, continuously scanning the heavens with unmatched vigilance. It processed terabytes of data using advanced algorithms and high-performance computing systems, allowing it to identify subtle changes, new stars, asteroids, comets, supernovae, and most notably, interstellar objects. But its mission extended far beyond astronomical curiosity. Pan-STARRS-1 was also Earth's early warning system, a guardian scanning the cosmos for near-Earth objects, NEOs, including potentially hazardous asteroids. By identifying these objects early, Pan-STARRS has played a pivotal role in planetary defense, helping scientists track and assess potential threats long before they come close. Its most groundbreaking moment came in October 2017, when it detected Oumuamua, the first known interstellar object to visit our solar system. This moment was historic, not just for what it revealed, but for what it suggested, that our solar system is not an isolated island in space, but a junction of interstellar highways briefly visited by objects from distant star systems. And as humanity stood at the threshold of this revelation, Pan-STARRS 1 became not just a telescope, it became a symbol of discovery. Its lenses captured a visitor from the stars. Its sensors chronicled a mystery that would ripple across the global scientific community. And its success reminded us all that when innovation meets collaboration, even the deepest secrets of the cosmos can come into view. In an age where space remains the final frontier, Pan-STARRS 1 teaches us that vigilance, unity, and the thirst for knowledge can bring light to the darkest corners of our universe, the gravitational norms of our solar system sparking intense debate among astronomers, astrophysicists, and theorists alike. It didn't just pass through. Oumuamua pierced the very fabric of scientific understanding, raising questions that echoed far beyond its fleeting visit. Unlike the icy comets and rocky asteroids familiar to us, Oumuamua bore no glowing coma, no tail of vaporized gas, traits typical of such visitors. Instead, its dry, tumbling, cigar-shaped body, estimated to be about 800 meters in length and only 80 meters wide, spun chaotically as it sailed through the inner solar system. This motion, irregular and unbound, suggested a non-gravitational acceleration, a puzzling propulsion not easily explained by the known forces acting upon it. Its reddish hue, revealed by spectral analysis, hinted at cosmic weathering, surface alteration due to countless years exposed to interstellar radiation. This coating, more than a colour, was a chronicle, a timeline of Oumuamua's ancient voyage across the stars, possibly spanning millions of years. But it was the unexpected acceleration, a subtle yet undeniable increase in its speed as it exited the solar system, that set the scientific world abuzz. This anomaly couldn't be attributed to gravitational slingshots or known gas emissions. No visible signs of outgassing, which typically propel comets, were observed. This forced researchers to consider more exotic possibilities. Some proposed that Oumuamua could be composed of pure hydrogen ice, allowing invisible sublimation to push it forward. Others speculated about the possibility of light sail propulsion, a concept involving a thin reflective structure propelled by radiation pressure, suggesting the remote possibility of an artificial origin. Harvard astronomer Avi Loeb famously fueled the debate by suggesting that Oumuamua might be a fragment of advanced extraterrestrial technology, perhaps a derelict probe or a piece of alien engineering, an interstellar relic drifting silently through space. While this theory remains controversial and unproven, it invigorated public imagination and highlighted the importance of remaining open to the unknown in scientific inquiry. Ultimately, Oumuamua was with us only briefly. After just 11 days of high-quality observation, it faded from reach, racing away from our sun and leaving more questions than answers. Yet in that short window, it changed the way we look at the universe. It reminded us that the cosmos is not static, that visitors from distant stars are not only possible, but real. It reignited our passion for discovery and exposed the limits of our current scientific models, urging us to refine our tools, rethink our theories, and remain ever vigilant. As the journey through Oumuamua's story continues, it becomes more than a tale of a wandering rock. It becomes a cosmic message in a bottle, drifting through the void, inviting us to read between the stars. Oumuamua is not just a mere object drifting aimlessly through space. It is a celestial enigma, a cosmic wanderer whose very existence challenges our understanding of the universe. Its behavior, a complex choreography shaped by gravitational forces and other unseen influences, whispers secrets about the hidden mechanics and subtle interactions that govern the vast cosmic stage. Amid the many theories proposed to explain Oumuamua peculiarities, one idea stands out as particularly compelling and grounded in astrophysical reasoning: the notion that Oumuamua is not an isolated wanderer born in solitude, but rather a fragment torn from a much larger celestial body. Imagine a violent cataclysmic event, perhaps the explosive collision of massive objects, or a gravitational dance gone awry, powerful enough to rip apart a star system's structure. From this colossal cosmic upheaval, shards are hurled forth, propelled across the vast interstellar void. Oumuamua, then, is one such fragment, cast into the void with tremendous velocity, journeying across millions of years and light years to arrive in our solar system. This perspective paints the interstellar space as a dynamic, ever-evolving tapestry, filled with remnants and relics of cosmic cataclysms, a celestial landscape where unexpected visitors can appear without warning. Each fragment, like Oumuamua, carries a story, a history etched into its shape, composition, and trajectory. In this grand theatre of cosmic exploration, Oumuamua's enigmatic nature fuels our fascination and curiosity, reminding us that the universe is full of surprises and that our quest to comprehend it is a never-ending saga. It beckons us to reflect on the mysteries still hidden beyond our current scientific horizons, and invites us to ponder profound questions about the origins and fate of matter travelling between the stars. The story of Oumuamua remains an ongoing cosmic narrative, encouraging humanity to look up, to keep searching, and to embrace the unknown with both wonder and scientific rigour. The mysteries that shroud our universe often seem impenetrable, veiled in darkness, scattered across the endless cosmic ocean. Yet time and again, human ingenuity and insatiable curiosity illuminate these shadows, revealing new chapters of the grand cosmic story. At the forefront of this quest stands the James Webb Space Telescope, a magnificent beacon of scientific advancement and a symbol of humanity's relentless thirst for knowledge. This marvel of technology, with its unprecedented sensitivity and power, is poised to rewrite our understanding of Oumuamua, the elusive celestial traveller that has captivated the world's imagination. As its sophisticated instruments hone in on the faint whispers of infrared light emitted from Oumuamua's surface, the telescope unravels details about its composition, origins, and enigmatic purpose, details once lost in the vastness of space. With each photon captured, the Webb Space Telescope pierces deeper into the secrets of this cosmic visitor, peeling back layers of mystery that have confounded scientists and stirred wonder in equal measure. It promises to unveil truths that challenge our wildest imaginations, truths that may reshape our cosmic perspective and push the boundaries of what we consider possible. As we stand on the precipice of this new era of enlightenment, ready to embrace revelations that may forever alter our understanding of the universe, Oumuamua's story becomes more than a tale of an interstellar object. It becomes a testament to human perseverance, collaboration, and the unquenchable flame of curiosity that drives us to explore beyond the horizons of the known. The journey into Oumuamua's mystery transcends scientific inquiry. It is a profound invitation to expand our minds and open our hearts to the awe-inspiring wonders that lie beyond our world. As the James Webb Space Telescope prepares to unlock the cosmic secrets hidden in the depths of space and time, we find ourselves on the cusp of discovery, poised to encounter the wondrous, the unexpected, and the truly extraordinary. In this mind-bending cosmic odyssey, we are reminded that exploration is not merely about answers, but about embracing the unknown with courage and wonder. It is a voyage that unites us all in the shared human experience of seeking, learning, and marveling at the vast, beautiful universe we call home.